Welcome to the new video. Today we are going to begin with the study of compounds second chapter, that is ammonia. So let's begin the video. Hopefully you all have watched HCl before. Okay, let's begin with ammonia. Ammonia, NH3. You have used ammonia in analytical chemistry also, not directly but indirectly, the ammonium hydroxide solution. So that is formed from ammonia only, right? So ammonia occurs in the atmosphere. I mean to say that it occurs in free state and in combined. That is in the atmosphere only, right? So first thing is the electron dot structure. So you all have drawn already. So if this is N, then let us take that here is one H, here is one H, and here is another H. So NH3. So this has got 1, 2. This has got 5. So 1 over clear. And let's take like this, and let's take like this. Clear? So this is the electron dot structure for nitrogen. It's not nitrogen, sorry, for ammonia. Clear? This is an ammonia molecule. Nitrogen at the center having one lone pair. This needs to be taken into care that it has got one lone pair. Okay. Do not write LP. What will you write it as? Lone pair. Clear? Do not write LP, right? Lone pair. Okay, I am writing here in short. Clear? So it has one lone pair of electrons. Clear? So it has got one lone pair of electrons. Okay. Next, occurrence. So as I have already told you that it occurs in the free state as well as in the combined state. So it will occur as free state in small amounts and in combined state in many forms, like you have got is ammonium chloride, then you have is ammonium hydroxide. Lot of things are there in which it can occur, like even urea. Okay, even urea, NH2CO NH2. This is urea, right? So you can write it as CONH whole twice. That is also same thing. So that is also it can occur. Clear? So these are all combined forms of ammonia. Okay, next. Have you ever seen organic matter lying, like a heap of organic matter? If you have ever passed by, then you will have got a smell, a pungent smell. What is that pungent smell? Due to ammonia. That pungent smelling gas is ammonia. Okay, now why an ammonia is there, how ammonia is there, that is very interesting. See, if we take urea is this, right? NH2CONH whole 2, that is same thing like this you can write. So if you see, this is urea. With urea, if it comes in contact with a moisture, then it will give rise to what? This gas plus this gas. You know already this one. Decomposition of organic substance by bacteria. Clear? Plus water is always there, so water. So this is what we get the smell of. Clear? Understood? So this is urea. When it reacts with water, it forms ammonia plus carbon dioxide plus water again. So whenever you pass by an organic matter, you will get the smell of, not smell actually, odor. Okay, odor. And this is pungent smelling gas. Clear? So this is the odor that you get when you pass by. Clear? Now forms of ammonia is there. That is aqueous ammonia. Then you will get is gaseous ammonia. Aqueous ammonia, you can understand, it's simple, it's liquid ammonia. Clear? Then is gaseous ammonia. Then you will get is liqueur ammonia fortis. Liqueur ammonia fortis. No need to know about it. It's 880 ammonia. Clear? That's not there. Okay. Next is preparation. General preparation you have already done in analytical chemistry. That is, whenever there is an ammonium salt heated with an alkali, it will release ammonia gas. Clear? Same reaction to be applied over here. Okay. Next is the laboratory preparation. Laboratory preparation of NH3. How? In the laboratory preparation, we use ammonium chloride to react it with calcium hydroxide. Alkali, correct? This is an alkali. So formation will be ammonia gas plus respective salt solution remaining is water. Clear? Understood? Balance the reaction. Okay, I have not balanced the reaction. Clear? So NH4Cl plus CaOH whole 2 NH3 plus CaCl2 plus H2O. This is the basic reaction. Whenever it is formed alkali, it will give ammonia plus water and the respective salt that is there. Clear? So this is the laboratory preparation reaction that you need to read. Laboratory preparation reaction NH4Cl plus CaOH whole 2 forms NH3 plus Cl2 plus CaCl2 plus H2O. Clear? This is the laboratory preparation of NH3. Acha. Now I had told you, remember, that Ca will go with Cl, NH4 will go with OH. So NH4OH could have been written. Why did we not write NH4OH? Because NH4OH cannot stay at NH4OH. It will dissociate into NH3 and H2O. That is why we have written like this. Clear? We could have written NH4OH, but that is not correct. That is wrong. You cannot write. Clear? Why? Because it is very unstable. It will decompose. It will decompose. Clear? Has to decompose. That is why when we have worked in the lab, if you have worked in the lab, then repeatedly it's told to keep the lid of the NH4OH bottle closed after you have used. Why? Ammonia will escape. So if ammonia will escape, what will happen? This gas escapes. Suppose NH4OH is there, right? From there, ammonia gas escapes. What is left over? Water. Do we need water for the reaction? No. We need this substance. But if this escapes, this cannot be the reaction. We need this. This escape. This is remaining. That is not the thing we need, right? That is why the lid of the ammonium hydroxide bottle has to be kept closed. Okay. So laboratory preparation, we need ammonium chloride. We need ammonium chloride. Okay. Now, next, in order to dry this ammonia gas, like in HCl gas, we had used H2SO4 concentrated. In case of ammonia gas, the drying agent that we will be using is CaO. Clear? We will be using CaO. See, in the last time we had used this concentrated sulfuric acid, right? Now, but here we cannot use that. Why? Because whenever you use that, it will react with this. It's very simple. But it will form NH4 whole 2 SO4. Clear? That is ammonium sulfate. So that is not what we want. Do we want that? No. P2O5 will also react with that to form ammonium phosphate, and calcium chloride is also drying agent, will react to form an addition compound CaCl2.NH3. Clear? Okay. Okay. Next, collection. This ammonia gas is collected by downward displacement of air. If you remember in HCl, we have done is HCl is collected by upward displacement of air or downward delivery of HCl gas, right? But here ammonia is collected by downward displacement of air itself. What does this indicate? Downward displacement of air. This term itself says a lot of things. Downward displacement of air. What does this mean? When can someone be displaced downward? When something is lighter. So ammonia gas can be stated as lighter than air. Clear? So ammonia gas can be said lighter than air. So if this is a container and inside the container I pour NH3 gas, then NH3 gas will be over here, air will be over here. Clear? So it will not be going down, right, as compared to HCl, which goes down, right? HCl will settle at the bottom while ammonia gas settles at the top. Why? Reason is it is lighter than air. Okay. Next, ammonia gas is highly soluble in water. You can understand that. It is highly soluble in water to form ammonium hydroxide solution. Therefore, the same reason is we cannot collect it above water. Simple reason, highly soluble in water. Next, in the reaction NH4Cl, if I write the skeletal equation NH4Cl plus CaOH whole twice. Clear? In this reaction, if you see, we need 2 NH4Cl to react with 1. Okay. First part I have written only, products I have not written. Okay. So you can see the 2. So ratio is 2:1. So 2:1. So whatever COH2 will be there, more the number of NH4Cl has to be there. That you can see. Clear or not clear? But in reality, this is more, this part. Why? NH4Cl is what type of substance? Sublimable substance. Right? NH4Cl is a sublimable substance. This substance is a sublimable substance. Sublimable substance. And a sublimable substance will sublime. So if it sublimes, do we need that? No. We do not need it to sublime, because if it sublimes, it will form something different. That is not the concern. So in order to reduce the rate of being sublime, it will sublime, that you cannot stop. But to reduce it, you can use more amount of alkali. So it will react immediately and prevent it from getting sublimed at a faster rate. Fine. So we use higher amount of alkali for this reason. That is to counteract the loss of sublimation of NH4Cl. Next, there was NaOH, KOH, lot of things were there. Why are we using COH whole 2? Simple answer, it is cheap and they are not deliquescent. Clear? This substance is specifically not deliquescent. Now what is deliquescence? We learned in class 9 that deliquescence is a property. Right? It's a property to absorb moisture from the atmosphere when being exposed. Right? And it will dissolve in the solution. Right? It will form a saturated solution and it will dissolve in. That is a deliquescent substance. But this is not a deliquescent substance. Clear? Okay. Next. Why are we using this substance? We have so many substances. Why this substance? Because other substance like NH4NO3, that is ammonium nitrate and ammonium nitrite, will not give you the proper results. Achha. If I write NH4NO3, this is ammonium nitrate. This one, if you heat it, it will not give you ammonia. What it will give you? It will give you nitrous oxide. Do we want that? No. Do we want nitrous oxide? We do not want nitrous oxide. We want ammonia. That is not coming as the reaction. Clear? Moreover, NH4NO3 is an explosive. Clear? This is an explosive also. So we do not want this. Do we want this? We do not want this. We want ammonia. It is not coming as a result of this reaction. Ammonium nitrite, that is NH4NO2. If you heat this also, you will get N2 plus H2O. Do we want that? No. Do we want this? No. What do we want? We want ammonia, that we are not getting. So both of this cannot be used. Clear? Okay, next. We can get ammonia from certain metal nitrites. Clear? Metal nitrites. Now this method is a costly method. Okay, let me tell you, this method is a very costly method. We use magnesium nitrite. Formula is Mg3N2, and we use this aluminium nitride. Clear? ALN. So if you add with this NH3, sorry, not NH3, definitely not NH3, we will get NH3. So if we add with this water, that is moisture, then you will get as NH3 as one of the products, and you will get its respective salt solution, that is MgOH whole 2 in this case. MgOH whole 2. Clear? That is a precipitate. So what will be in this case? Along with added with water, so formation will be ammonia gas obviously, and another product will be aluminium hydroxide, that is AlOH whole 3 plus H2. Clear? So whenever you add Mg3N2 with H2O, you get ammonia gas, along with that the respective hydroxide. Clear? Okay. Next comes manufacture of ammonia. Manufacture of ammonia. That is Haber process. Heard the name? Yes, definitely I have heard the name. Read in class 7 also. Haber process is the process that is used to prepare ammonia. Right? One reaction occurs in this. One important reaction that you have to do. That's very easy reaction. N2 plus H2 forms reversible reaction NH3. Right? This reaction you have been learning. Right? N2 plus 3H2 forms 2NH3. Find this reaction. What is different in class 10? Yes, there is something different. That is conditions. You need to remember what conditions are here needed. What conditions are needed? First condition. Condition number 1. Temperature. What temperature will this reaction take place? 450 degrees Celsius to 500 degrees Celsius. Right? Wrong temperature? No marks. Clear? No half marking. Next, number 2. Number 2, pressure. Pressure. I am writing in short P. Okay, P is pressure. Pressure has to be greater than 200 atm. Clear? This atm does not stand for automatic transformation, please. This is atmosphere. So above 200 atmosphere. It is above 200 atm. Clear? This is pressure. Next, catalyst. Their catalyst presence is very important. Clear? Catalyst. Next condition that you need is catalyst. Next condition needed, catalyst. Point 3, catalyst. Who is the catalyst? Finely divided iron. Who is the catalyst? Finely divided iron. Clear? Finely divided iron. Next, number 4 condition. Promoter. Who will promote the reaction? Who will promote the reaction? Molybdenum. Clear? Who will promote the reaction? Molybdenum. Molybdenum. Clear? There are 4 conditions needed. Temperature 450 to 500 degrees Celsius. Pressure above 200 atm. Catalyst finely powdered iron or finely divided iron. Promoter molybdenum. Clear? These are the conditions that will be asked. So you have to write this answer properly. Clear? Next coming to chemical properties. Directly chemical properties. Chemical properties of ammonia. Chemical properties of ammonia. Chemical properties of ammonia. Let us see. What chemical properties does ammonia have? Chemical properties. First, let us discuss about color change. Litmus, red to blue. Litmus, red to blue. Methyl orange, orange, original color, change to yellow. Phenol pH phthalate, colorless to pink. Clear? Methyl orange to yellow, and phenol pH phthalate, colorless to pink. Great. Next. Oxidation of ammonia in absence of catalyst. Oxidation of ammonia in absence of catalyst. Oxidation of ammonia in absence of catalyst. Note my words. Absence of catalyst. If catalyst is absent, a reaction will result in the formation of nitrogen gas and water. Clear? Nitrogen gas and water. Clear? What observation will you give for this? You cannot give any observation for water. You cannot give any observation for this. You have only one observation for ammonia. That is not pungent smell, but it burns with a greenish yellow flame. Greenish yellow flame. One observation only. Ammonia burns with greenish yellow flame. Clear? Next, catalytic oxidation. Catalytic oxidation. Now see, one change will happen. Whenever there is a catalyst present, it will boost up the reaction. Who is the catalyst over here? Mr. Platinum. Temperature goes to 800 degrees Celsius. Clear? Who is the catalyst? Platinum. Temperature 800 degrees Celsius. Result will be N2 will become NO, not no, but it's nitrous oxide plus heat. Clear? Or nitrogen monoxide rather. This is nitrogen monoxide. This is clear? Understood? Clear? Another product is this. Definitely this will remain. Clear? So NH3 plus O2 forms NO, that is nitrogen monoxide plus water plus heat. It's an exothermic reaction. Clear? I think that omitting this also is okay. So whenever catalytic oxidation is happening, when platinum is present at 800 degrees Celsius, reaction instead of nitrogen forms nitrogen monoxide because it's getting oxidized. Clear? Next, ammonia. Observation. Sorry. Before we move on to the next observation, what observation will you get? See, this NO has got no observation. There is no observation. But NO is a very unstable compound. It will combine with another O to form, NO2. Clear? So if NO will combine with O2 to form NO2, then what will happen? Observation for this you write. Observation, dark reddish brown. Clear? Reddish brown fumes. Simple observation is there for NO2. Reddish brown fumes. Only observation, reddish brown fumes or reddish brown vapors. Clear? Understood? Okay. Next, reducing property of NH3. Reducing property of NH3. What is reducing property? What do you mean by reducing agent? Itself will go under oxidation, but it will reduce the closest friend. Okay. Suppose NH3 is there with CuO. What will happen? Suppose NH3 is a very close friend of CuO. Clear? Itself will go under oxidation. Itself will go with oxidation. What is forming after oxidation? H2O. Gone oxidation. Plus N2. But it will reduce this percent to Cu. Clear? So reaction results in this. Clear? So reaction results in Cu sitting alone, N2 sitting alone, H2O. Clear? This is showing the reducing property of NH3. This is showing the reducing property of NH3. Clear or not clear? This is showing the reducing property of NH3. This is the reaction to show the reducing property. Color change is very important. Color of this is a black. Color of this is not black. Pink deposit or reddish brown deposit. So color changes to reddish brown or you can mention as pink. So color changes from black to reddish brown or pink deposit. Clear or not clear? Clear or not clear? So this is a reducing property of ammonia. This is reducing property of ammonia. Understood? Reducing property of ammonia. Clear? Okay. Another example we can take is that instead of CuO, if we take here, let us take over here PbO, then what will happen? Same thing will happen. N2 plus H2O plus Pb. Color change, color yellow. Color of lead, silvery gray. Clear? So color changes from yellow to silvery gray. So you have to remember the observations because observations will be asked in the question. Right? Observation will be asked in the question. So you need to read the observation. Next, the last important reaction that you have in your syllabus. Last two important reactions. Please note this reaction is very important. This reaction is very important. Two reactions you will think the same thing will come, but no, it's not the same thing coming in both the cases. See, I am writing NH3. Fine, I am writing again NH3. Two reactions simultaneously will be plus Cl2 written plus Cl2 written. And I will say both the products will be same. It's not the same. Two products are different. Both the reaction products are different. Let's check. First case, we are putting ammonia into excess, and second case, we are putting Cl2 into excess. Now think what will happen. If you cannot remember, confusion occurring. Cl is in excess, no? So Cl will tend to combine with this person, entire person. So what will it form? When Cl is in excess, it will try to combine with NH3. Right? It will try to combine with NH3. Clear? Think logically. Cl2 is in excess, so it will try to combine with NH3. Now here also NH3 is in excess, it will try to combine with Cl2. Now you think, who will form NH4Cl? Will Cl combine with NH3 to form NHCl2, NH4Cl, or NH3 in excess will combine? NH3 in excess. Because NH3 with Cl2 always has to react to form Cl, NH4Cl. But Cl2 plus NH3 can form other products, like in this case, it will form other products. What product will it form? It will form nitrogen trichloride. So this person will react with only this person to form, clear, NCl3. Another person remaining is from here and from here. So it's plus HCl, valence reaction. Clear? Now here this person is in excess, so this person will tend over this person to form NH4Cl. Clear? And what else is remaining? What else is remaining? N2. Clear? So what notice? NH3 combined with Cl2, NH4Cl has to be there. Cl2 combined with NH3, necessarily this person might not be there. Does not have to be there. Clear? Here NCl3 is being formed. So whenever chlorine is in excess, nitrogen trichloride has to be formed. Chlorine excess. Case of ammonia excess, product from this ammonium chloride. Clear? With this, we come to the end of ammonia chapter as well. So it was quite a long chapter, but it's easy chapter. HCl was also easy. In the next video, we will be talking about the next chapter, that is HNO3. That is the third part of study of compounds. So see you all in the next video. Hope you have enjoyed. Thank you.